In Chapter 3, we're adding a little bit when we're talking about solving equations to solve things called literal equations. So by the end of this lesson, you should be able to solve literal equations for a specific variable. So a literal equation is an equation with two or more variables in it. So that means that we won't be able to get an answer like x equals 3 because it's going to have more than just an x in it. So let's say we have this triangle. We know the area of a triangle is 1/2 base times height, and we need to solve for height. And then find the height of the triangle if the area is 48 and the base is 4. So most people just want to plug this in and get the answer out. But the directions say that we have to solve for h first. So forget that that stuff is even there. We'll do it afterwards. But when we're looking at this formula right here, we need to get h by itself. So we want to approach this just like we would any other problem if there was actual numbers in there. So 1/2, b, and h are all being multiplied together. So the first thing I want to undo is that 1/2. So remember, to undo multiplying by 1/2, we can multiply by the reciprocal, which is 2/1, or just 2. So this crosses off with that, and I have 2 area equals base times height. Now h is almost by itself. I gotta do one last thing. Gotta undo this base, and because they're multiplying, the opposite's division. So we end up with the height of any triangle is 2 times the area divided by the base. This is a literal equation because it has more than one variable in it. It actually has 3. And I can't give you a specific answer. I can't tell you what the height is. I can just rearrange this to write it in terms of the height. So if I want to find the height, there's 2 things I need to know. I need to know the area, and I need to know the base. So they told us those 2 things. The area is 48, and the base is 4. So all we have to do is plug them in. 2 times 48 divided by 4. So we end up with 2 times 48 will give me 96. And if you divide that by 4, you can think 4 goes into 9 twice with 1 left over, and it goes into 16 4 times. So the height has to be 24 inches. So let's do another one. So this time we're going to solve a times b minus d equals c for b in terms of ADC. So when we see the solve for b, this means get b by itself. And in terms of ADC means our answer is going to have those in it. Remember, we won't be able to get an answer like 6 out, but we'll have b equals something about a, d, and c. So we take a look at what we start with and pretend there are actual numbers here. If we are trying to get b all by itself, remember we have to undo PEMDAS. So the first thing I want to do is get rid of this minus d. So I'm going to add d to both sides. And normally when these are numbers, we can actually add them together. But since I don't know what c is and I don't know what d is, we have to just write it c plus d. And now a and b are multiplying. So to undo multiplication, I want to divide by a. So I end up that b equals c plus d all divided by a. So we solved for b, and it's in terms of a, d, and c. And that's it. So the reason we do this after solving is because you still have to use the same rules. It's just not with numbers. So those people that like to do things in their head, make sure you know the processes behind them, because that's not really going to help you out here when there's no numbers. So hopefully this formula looks familiar, that the Celsius temperature is 5/9 of the quantity of the Fahrenheit temperature minus 32. So we need to transform the formula to find the Fahrenheit temperature in terms of Celsius temperature. So that means get F by itself. So if we start, C equals 5/9, F minus 32. So if we go backwards, we got to get rid of this 5/9 before we can do anything with the 32. So I'm going to multiply both sides by the reciprocal, which is 9/5. Whatever you do to one side, you got to do to the other. So that crosses off, and I get 9/5 of my Celsius temperature equals my Fahrenheit temperature minus 32. And then I'm going to add 32 to both sides. That crosses off. And then this right here we can't combine because one is a C and one doesn't. So I'm just going to leave it as 9/5 times Celsius plus 32. And that gives me my temperature in Fahrenheit. So we're at the end. Can you solve literal equations for a specific variable? A, you're doing that. And then B, you're using that knowledge to find H for 4 different volumes of cubes. Make sure you write down any questions you have and we can go over them tomorrow. Have a good night.